keep on continue with review of circles. There's a lot of information in this chapter that we need to talk about, so be patient. And so again, remember the circles. When an angle is formed at the center, it's exactly the same measure as the arc. When an angle is formed on the circle, it's about 1/2 of the intercepted arc. When an angle is inside the circle but not at the center, it is 1/2 of the sum of the angle in front of it and behind it, the arc in front of it and behind it. If the angle is outside the circle, then it's going to be 1/2 of the big arc minus the smaller arc. Okay? Okay, so let's solve a problem. Here we are given that the measure of arc Z is 110. Now, in terms of the large circle, that arc is on the larger circle. So this angle P is on the circle, on the larger circle. So that angle is going to be 1/2 of this larger arc because it's inscribed. So that angle is going to be 55. Now we're asked to find the arc YZ. So arc YZ, which is this arc here. So let's label it X. Now, we don't know the other part of the angles, arc I mean, so we can label it is 360 minus X because this arc X plus arc from what is left, 360 minus X is going to make 360. So whenever we do not have a number for any part we are looking for, either angle or segment or arc, just represent it with a variable and then write an expression there. Once you set up an equation, you will find what to do. So we know now for this angle is external angle for the smaller circle. You see, is that outside this smaller circle, but these two sides are tangent. See, so angle 55 is going to be 1/2 of the major arc. Now the big arc is going to be 360 minus X. So it's 360 minus X minus the smaller arc, which is just X. Okay? Get that? Now just do the algebra. So we can multiply both sides by 2 to get rid of that 1/2. And that will give us 110, which is going to be 360. Then negative X minus X, which is negative X, plus negative X, which is negative 2X. And now we can subtract 360 from both sides. Okay. 0 minus 360 is negative 250 equals negative 2X. And we can divide both sides by negative 2. Okay, and we get 125. And since 125 is the X, which is the arc we are looking for, XW, that's our answer. Again, we know it's the smaller one because it's written with 2 variables. Okay, 2 letters. Now think of inscribed and circumscribed polygons. When we have inscribed polygons, if the polygon is inside, inscribed is inside the circle, so the circle would be circumscribed. Here, the circle is inscribed, the quadrilateral is circumscribed. So we need to remember when that happens that the opposite angles are supplementary. So angle B and angle D will be equal to 180. Angle A plus angle C will be equal to 180. And when it is a polygon is circumscribed, that these two sides will be congruent. So yeah, so we need to remember that. The same thing with here and here and here and there. Okay. A parallelogram with sides 4 and 7.5 is inscribed in a circle. So there's a theorem that if a parallelogram, once it is a parallelogram, means opposite sides are parallel, is inscribed in a circle, that parallelogram must be a rectangle, nothing but a rectangle. So is it a rectangle? It could also be a square because a square is a rectangle. So if we draw a rectangle, we don't know how, since it is inscribed, all the corners should be touching the circle. Okay, so sorry, take that as a rectangle. Okay, it's a rectangle, all the sides are congruent and the opposite sides are. So if this is 4, this would also be 4, and that's 7.5 should be the longer one, 7.5. We're asked to find the radius. Okay, well, the radius is going to be from the center of the center of this, going to have the same center to one of the vertices. So we can draw the whole length, which is going to be the diagonal of the circle, and that's going to be the diagonal of the rectangle as well. So let's call it the D, the diagonal or diameter. So we're going to find the diameter, and diameter is going to be twice the radius. So once we find the diameter, we then use it to find radius. So using Pythagorean theorem here, so the triangle, okay, on part of this right triangle, so D squared is equal to 4 squared plus 7.5 squared. So D squared is 16 plus 7.5 squared, which is 56.25. So if we add that to 16, we get 72.25. And then we take the square root of that, 72.55. And that will give us 8.5. 8.5. So 8.5 is the diameter. And so diameter is 8.5 equals to radius. So if we divide that by 2, we get the radius. Okay, and that will be 4.25 radius. So again, it's all about making connections. Okay. So remember, inscribed quadrilateral, like I said, it's going to be add up to opposite angles, add up to 180. So quadrilateral, this is quadrilateral, means 4 sides. It doesn't have to be parallelogram. Parallelogram is also a quadrilateral, but this is any quadrilateral at all. It's inscribed in a circle, so we draw a circle. Draw any parallelogram. We don't know how it looks, but we know given the ratio, all the sides are different. So if one side is like, it says the vertices divided into 4 arcs. Okay, 4. It's going to be 1, 2, 3, 4. So let's say that this is the larger arc. The arc is in that ratio. We don't know what that is. Okay. So let's just label them, maybe this segment A, B, C, D. Okay, so let's add the whole arc, the sum of the arcs, so which will be 1 plus 2 plus 5 plus 4, which will be, which is 12. So it's going to be 12. And so since the whole arc is 360, we can find each one of them, each one of the arc. And so 1 out of 12, what would that give us if we are looking for, let's say the arc A over 360. What is that going to be? So we can just cross multiply that. So 12A equals 360. So A is going to be 360 divided by 12. That's 30. And then, so we do the same thing for 2 over 12. Let's say the 2 is the B1, B over 360. So 12B equals, we'll multiply those. So 360 times 2 is 720. So B is going to be 720 divided by 12. That is 60. And that makes sense since that's 30, that is maybe twice that. If it's twice that, since A is the smallest one, B is going to be 60. So this is 30, this is going to be 60. And we can just go ahead and since A is the one, we can just multiply that by 5. So 30 times 5 is going to give us 150. Let's say this is the 151, the D. C, 150. And then 4 times 30 also. Okay, it's going to be 120. So this arc here is 120. Okay, those are the measure of the arcs. And then we're asked to find the angles. The angles. So with the angles we are looking for. So let's label them again. I don't know. X, Y, T, H. Okay, so we're going to find the measure of angle X is going to be this intercepted arc here. It's going to be 1/2 of this intercepted arc because it's inscribed is on the circle. So X is going to be 1/2 of 150 plus 120. Okay, so 150 plus 120 divided by 2. So 135. X is going to be 135 degrees. So that's one of the angles. So to find Y, okay, angle Y, again, you see the intercepted arc, it's going to be 60 and 150. We do the same thing. Angle Y is going to be 1/2 of 60 plus 150. So 150 plus 60 divided by 2, which is 105 degrees. That's another one. Okay, we keep doing the same thing for all the remaining angle T. So T is going to be 1/2 of that, of 30 plus 120. And that is 30 plus 120, 75. And the last one, H, is going to be 1/2 of 60 plus 30. Okay, 60 plus 30. Which is 45. Degree. Okay, remember the segment relationship. Okay, these are the 3 things you need to remember. The part times part equals part times part for the quad. Remember to use the whole segment A plus B, not A times B, A plus B times the part that sticks out. So here, this is the tangent, so it's going to be 12 squared equals x plus 8, because we have to use the whole length, x plus 8, times 8, the part that sticks out. So distribute, so we have 144 equals 8x plus 64, subtract 64 from both sides, we get 64, we get 80 equals 8x. So x, divide both sides, x is 10. Since we are just solving for x, we are done. And then the last one is going to be 9x equals 6 times 15. Okay, 9x equals 6 times 15 is 90. So x is going to be 10 also. Study hard. Those who sow in tears will reap in joy. That's Psalm 126. Good luck. Be well prepared.